Okay, so we can see from the sigma that the formula is 3k minus 2. So we started our lower limit of summation being 1, put in a 1. So 3 times 1 is 3, minus 2 would be 1. And if you look at t2, we're going to put a 2 in. So 3 times 2 is 6, minus 2 would be 4. Putting in our next number would be 3. So we have 3 times 3 minus 2. So that's 9 minus 2 is 7. And T4, we put a 4 in. So 3 times 4 is 12, minus 2 is 10. And then we put our 5 in for T5. So 3 times 5 minus 2, so 15 minus 2 is 13. And if we sum all those numbers up, that should be 35, which is the sum of the sigma of all the terms. But the actual question was to write out all the terms. So 1 plus 4 plus 7 plus 10 plus 13. And we stop at 5 because the upper limit says stop at 5. That's the last number you're going to put into the sigma notation. Okay, so the next question, we're being asked to write a sigma based on this pattern of numbers. And so I think the best place to start is the formula. You kind of want to create a formula for yourself that would allow you to get all of these numbers. So I'm going to start with my first number 3. And then it looks like what I'm doing is I'm adding 3 to every number after that. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, and so on. So I'm going to say plus 3. And then I got to figure out what I'm going to put as my formula. So this is where I kind of need to know what the lower limit of summation is, like where I'm going to start. And you can use any variable you want. I think generally we see the letter k here, but you could make an n if you want to feel more adventurous. But I'll start with k here. So somehow I've got to have a formula that has k. And when I plug numbers in, I've got to somehow get my first term to be 3. So the first number I could plug in is maybe make it a 1. So let's make k 1. Okay. So if I make it a 1, then I got to figure out what would I make for my statement here. So my first term is 3. Well, I really need this part here to be 0 for my first term, and that would just leave me with 3 plus 0. So what I could do, I guess, is add 1 to, or actually minus 1. Let's try that. So it's minus 1 here. So minus 1 from that. And so if I put in 1, I get 1 minus 1 is 0, times 3 is 0, plus 3 is 3. And so I could write that here then. So that's my formula. And now what I got to do is figure out what am I going to put for my upper limit. Like when would I stop doing this? So one way to do this is there's actually a pattern here to figure out the number of terms. And we'll show you the formula here after that. But let's just sort of figure out how we can get this without a specific formula yet. So I know that I'm going to be plugging in integers from 1 up. So if I plug in 2, I'm going to get 3 plus 3 times 2 minus 1. So that would give me my 6. So that's obviously that one. And if I plugged in a 3, that would work. And so what I've got basically is 3 plus 3 times k minus 1. And I've got to figure out what value for k would I put in to get my last term of 15. So if I move the 3 over, I get 3 times k minus 1 equals 12. I divide by 3, I get k minus 1 equals 12 divided by 3 is 4. And then that would give me a k value of 5. So it just says I need to put 5 in to get my last term. So my upper limit would have to stop at 5. Now, if you look, there's actually 5 terms in the actual series. 1, 2, 3, 4, 5. And so the formula for finding the number of terms is always the upper limit minus the lower limit. So I'll use U for upper, L for lower, and then add 1. So if I do 5 minus 1 plus 1, there should be 5 terms. So what if you were trying just create a different formula? So well, I'm going to just lower limit to be, let's say, where is it here? Let's see. Ooh,